Welcome to Amazement Square Anywhere. I'm Miss Tammy.
And I'm Miss Jennifer.
And today we're talking about liquid nitrogen. Jennifer, show us all about liquid nitrogen.
All right, so liquid nitrogen is something very, very cool, but also very, very cold. So we actually have some in this dewar here. And by its name, it is a liquid. So it's about negative 320 degrees Fahrenheit. Wow. So for us to use it today, we have on our safety goggles, and I'll be also wearing some gloves. Now I'm gonna pour a little bit out for you all to see. I'm gonna put some right in this beaker here.
Wow.
Now, as you can see, as I'm pouring it out, you see kind of some smoke almost coming off. And that's just some of the nitrogen evaporating. We'll pour a little bit more in here. Alright, set my dewar here on the ground.
Can I ask you a question?
Yes.
If it's cold, why does it look like it's boiling?
Well, that's an excellent question. So it is actually boiling. So because it's so cold, the energy that's in this room is actually enough heat to cause it to boil. So it looks very similar, but because it is boiling. So we're gonna see what happens when we get some things very, very cold. And we're gonna start with air. So we have a balloon here. And we're gonna see what happens when the air inside our balloon gets really cold. Tammy, what do you think is gonna happen?
I don't know, but I'm really curious.
All right, well, let's find out.
Okay.
So we still have some liquid nitrogen there. It's kind of calming down just a little bit, but still boiling. You can see it boiling there. I'm gonna dip our balloon in. There you go. Now, right now, it seems to be a little bit stuck. Let's see if we can get a little bit closer to the nitrogen. See if anything happens.
It looks like the balloon is getting a little bit smaller.
It's getting a little bit smaller. It's because it's not as hard to put it out. Let's see. There we go. So our balloon was a little bit bigger than the beaker, but as it got just enough room to get inside, we started to see something happening. What's going on in there?
It's shrinking.
It is shrinking. So it looks nice and shriveled, kind of like a raisin. So we're gonna let it sit there just a moment. We hear a little bit of crackling too. Let's make sure it gets nice and cold. All right, let's see what happens when we pull out.
Okay.
So inside our balloon actually appeared to shrink.
Wow.
So as we set it back out, it should start to expand back out again. So what's happening is those molecules of air are getting really close together. So kind of like if you're very cold outside, do you want to be really close to someone or far away?
Close.
Yeah, because we're shivering too. So the molecules are basically shivering. So they're getting really cold, they want to get closer together. That caused our balloon to shrink. But as soon as we got it back out, it warmed back up again, so those molecules could expand back out to its normal size.
Excellent.
We also have some solid things with us too. So we have a racquetball and some flowers as well. So our racquetball is normally very bouncy. So what do you think might happen when we get this very cold?
Now, is it gonna shrink like the balloon? I'm curious.
I don't know, it might.
Okay.
Any guesses on our flower?
Is it gonna shrink too?
Well, I think we'll just have to see.
Okay.
All right, so what I'm gonna do, we're gonna pour some of our liquid nitrogen into our smaller beaker here. All right, so now we're gonna put the racquetball in our smaller beaker. And Miss Tammy, if you could hold that down with the tongs just to make sure it stays nice and cold.
Okay.
So we're gonna look at our flowers next. So our flowers are a little bit more delicate, and let's see what happens if we just put the flower part in our nitrogen. So we're gonna get it nice and cold.
It's not shrinking.
I don't think it's shrinking the same as a balloon.
Okay.
So let's see. So we can bring it out. Looks like it opened up a bit.
Wow.
And it actually shattered. So even solids, the molecules are actually getting closer together. Let's see if we can do that to another one. So those molecules are getting closer together in the solid, but they don't appear as different as they did with our gas. But they're getting so close together it's becoming brittle. So even something as delicate as these flower petals are becoming brittle enough to shatter.
That's amazing.
Yeah. This is actually something used by perfume industries as well, because this is a great way to get those scents from flowers that's a little bit easier than trying to scrape it off when the petals are nice and soft. So now, let's see if we can check on our racquetball.
Okay, it didn't shrink,
Okay. Now, racquetballs are normally very bouncy. So let's see how much this will bounce when it's nice and cold.
Okay, you ready?
Yep.
All right.
All right, here we go. 2.
It shattered too.
Yep. So even something as bouncy as this racquetball shattered as well. It looks like it did a nice clean shatter in half. That's pretty cool. But we'll give it some time to actually warm back up to room temperature, and it might change a little bit because right now it's very hard. So give it some time to warm up to room temperature. And maybe we'll see if those properties go back to the way they were.
Okay.
But today we're actually using liquid nitrogen to make something very cool, ice cream.
I love ice cream.
Excellent. So there's actually quite a few ice cream shops around the country that use liquid nitrogen to make their ice cream because it can freeze instantaneously.
Wow.
And even Dippin' Dots are made using liquid nitrogen, which is pretty cool. So we're gonna start by making our ice cream base, which is the same base you could make to make ice cream at home. So we're gonna start with some whole milk and half and half.
Okay.
So Tammy, if you could pour about equal amounts of whole milk and half into our metal tray here.
Okay.
All right, that looks great. So then I think we want some extra creamy ice cream.
Yes.
Excellent. So we're gonna add a splash of heavy whipping cream as well.
Okay.
And you can decide how big a splash is.
Okay.
All right, I think that looks good. Now to finish off our ice cream base, we'll need some sugar and vanilla. So probably about a cup of sugar and just about a couple teaspoons of vanilla.
All right. So a cup of sugar.
And the base we're making here is just your basic vanilla ice cream base that you could add other things to. But we're gonna keep it nice and simple today.
And 2 teaspoons of vanilla.
About 2 teaspoons.
Okay.
So now I want to go ahead and stir all of that together. Now, as I said, this ice cream base is just your classic vanilla, but then you can add other things too. And you can also use this base to just put right into an ice cream maker or in the freezer if you're making it at home. But we want to freeze it a lot more quickly. We're a little impatient here for us some ice cream.
You're right.
So we're going to use our liquid nitrogen. So I'm going to pour some more into our smaller beaker here. So we can add it in. Tammy, ready?
I am ready.
All right. So we're gonna pour some in to our base, and Tammy, you can go ahead and start stirring. Now as we pour it into the liquid, even though our liquid was pretty cold, we just got it right out of the fridge, it's still a lot warmer than the liquid nitrogen. So we see it evaporating much more quickly. So that's kind of this nice fog effect that we're getting.
I have a question.
Yes.
So we poured liquid nitrogen into ice cream, but I want to eat this ice cream. Is it safe to eat?
It is safe to eat. So the nitrogen itself is really just evaporating off, so there's not going to be any left in our ice cream. The nitrogen also makes up about 68% of the air we breathe. So even all of this nitrogen coming off is perfectly fine for us to breathe, as it's the primary gas we're breathing in every day. All right, how does it look, Tammy?
I think we need a little bit more.
All right. Let's get a little bit more nitrogen in there.
Wow.
So when you first add the nitrogen, it gets a little bit clumpy because it's freezing very quickly. And as you keep stirring, it's going to be that nice, smooth, creamy ice cream we're looking for. And generally when you're making ice cream, you typically hear putting in an ice cream maker or kind of a ball that you roll around. You want to continually keep moving that liquid around as it's freezing so it's nice and smooth and creamy. So with making with liquid nitrogen, because it's freezing so quickly, it's a much creamier ice cream than when we typically make it at home. All right. So now we're stirring a little bit, getting it off the edges there. You think a little bit more liquid nitrogen?
Maybe just a little
All
bit.
right. just a little more
close.
to finish it off. There we go. And as Tammy finishes stirring, we'll have our very own liquid nitrogen ice cream. Now for you all to try at home, we have a downloadable that has a recipe and directions to make your own ice cream. But instead of using liquid nitrogen, we have ice and ice cream salt, which you can buy at the grocery store next to your table salt. And that's a great way to make your own quick ice cream at home. All right.
All right, so we have ice cream.
Excellent. So thank you so much for joining us to make our own liquid nitrogen ice cream. And make sure to send us pictures and videos of you making your own ice cream at home using the ice and ice cream salt. And remember to join us again next time on Amazement Square Anywhere.